All right, we're back. Sorry about that. Should cut the last video off short. I hit the wrong button. I hit the stop button instead of the pause button. All right, we left off here. Our offices. I just got to notice that our office is flooded at the Cypress Center. Place always floods. So we left off in here. So we'll start video 4 right here. Talking about this being a sash block with a pre-molded keyway in it, with an expansion joint, preformed gasket, and we're under control joints, which allow for some expansion, but are not true expansion joint like we had up here. All right. This is put backer rods on both sides and caulk. Joint reinforcement should be interrupted to allow plane movement. This is a pre-molded control joint. It'd be like a PVC water stop or something like that. Now, movement joints are also required to prevent the deflection of a steel or concrete structural frame from placing stress on a supported masonry wall or panel. You can see 7.28. We will cover that. Control joint spacing. Again, this is a rule of thumb. Your mileage is going to vary based on what your structural engineer says for your expansion and control, and your building codes. Okay, but these are rules of thumb. All right. Wall length of 50 feet. You need them every 16 inches. 60 feet, 8 inch or whatever. Okay. Wall height ratio. But again, check your building code. If you're in a seismic area, it's going to be a whole lot different. All right, so we're at here. 523. Masonry wall sections. Masonry covers a lot of real estate. There's a lot of moving parts in this. These are all different types of terminations at the top of masonry walls. You would basically build a hollow core for this one, and take a hollow core and make you a concrete perimeter beam. There would be reinforcement in this if it's done properly, horizontally. You put a double sill plate of wood up here. This is cast in with the grout, and then tighten that down. And then you would set your roof joist. Your roof joist would come in like this. And then your top roof joist would come in like this. And hopefully it would be pocketed. You would want to pocket these and come up. And if your carpenter's worth of salt, he will come and cut these off vertically. Then this will be bobbed. That'll be cut. So that's a scab, and that's a scab. So you'd cut them, and this would go away. It's going to erase the whole bloody thing, so don't do that. All right. But these pieces drop off, and problem with this is when you put your drip flashing up here, you want to keep it away from your wall. So this stuff might have to be extended further out. If I was going to do this, all right, let's go ahead and erase all this. If I was really going to do this for my house, this would be extended out. The joist would be. And then my roof rafters would come in like this. they extend it over, and they would be cut plumb to the ground. This would be my fascia. This would be bob squared with this roof joist. This would be the soffit, where you put your soffit, and this is where you nail your fascia board to. All right, here's an example of a wood joist. We use one of the C blocks, and we have a cast-in bolt, and you put a nailer strip all the way around, and then you hang a metal joist hanger. You nail a metal joist hanger into that, and then set your joist in the hanger. This allows for some thermal movement back and forth also. And then you put your subflooring up here, your underlayment, your decking, or whatever, and you make that as a diaphragm if you can. There are insulation options. Most insulation options are you put your insulation out in here, although some architects are beginning to put standoffs on the outside of these walls and putting the vapor barrier and the insulation out here, and then putting a skin over that, like vinyl siding or hardy plank or something like that. We'll get to surface bonding in a minute. Let's come here and look at this. All right, here's a built-in pocket. You put a header beam up here. This is a 2-wythe structure. This is a non-cavity wall. It's a solid wall. This is grout, the way that's detailed. And your joist sets on top of that with your deck. And assuming this is your roof line, and it is, then you'd have your flashing. And it doesn't necessarily have to be concrete up here. It could be insulated, rigid insulated panels, glued and screwed to the deck, and then you built up your roof on that. Minimum barrier length, 4 inches to 6 inches. Again, your mileage is going to vary. That will depend upon your structural engineer. What do we have here? A wood floor joist with a fire cut end. All right, this is what he's talking about. Joist. Now this is kind of funny. I find this humor. There's a metal tie that serves as a semi-hanger, if you will. I don't like this detail, but nonetheless, the bottom line is, so if you get a fire out here in the structure and the joist burns, then the joist can fall at this angle. It'll pull it out of the pocket, and it won't pull your wall down. I don't particularly like that idea. This joint system serves the same purpose. It was a lot less hassle to put it together and build it. Okay. I mean, those nails in the side of there are not going to keep this from pulling out and falling. If this beam burns in the middle, it's going to break anyway. It's not going to yank your wall down. But so let's look at surface bonding. Surface bonding is your dry stack in the masonry units. These concrete CMUs. That's surface bonding. There's no grout in between here. There may be the grout in the pockets where you want it reinforced, building it up. And then the idea is to come and you trowel on a surface bond, sort of like stucco. He calls it a cementitious compound containing sharp glass fibers. Now, there was an epoxy cement company called Surebond years ago. My ex-father-in-law used Surebond on the cement masonry units for his garage on his beach house down in South Padre Island, and it survived tidal surges. And it was an epoxy-based cementitious coating with cement fibers in it. Glass fibers, fiberglass in it. And literally you use plastic wedges to level your blocks. Leveling these blocks as you're building a regular mortared wall would be done with your mortar. But you'd use these plastic wedges, and then you would when you got everything lined up and plumbed and level, then you come on the outside, mix that stuff up, and trowel it on the outside of the block. And I thought it worked pretty well. Is it as strong as a traditional CMU masonry system? No, I don't think it is. They claim it is. The company that sold this stuff claimed it was. But it survived hurricanes down there and tidal surges. But he did put a lot of vertical rebar through the cells. And so that's just another way of taking care of this. But it's called surface bonding, as opposed to bonding in between each stringer of masonry. Okay. All right. Composite masonry bearing wall. Okay. A composite masonry. All right. Okay. Here's your facing white, that face outside. Hopefully you're using high fired clay masonry units. This is your backup white, and this is your. He shows a collar joint, but he doesn't detail it very well. These are joints in here that are filled with grout, and you have, of course, your metal wall ties tying the withes together. You'd have ladder ties going back that way, and these are cross ties, and these are a single cell going up. So I'm not a real fan of this. It's not as strong as laying them like this and filling every other cell up with grout. This is a Rolox seal up here. I'm not a real fan of this. It's expensive, and you're asking this mortar to survive the weep holes and the flashing and stay up there with all the building movement over the life cycle of the building. I think this is a bad detail. It's a bad way of doing it. A better detail is to put another regular course of masonry up here. Finish this off. Put a treated flash cap out of wood. Fill this all full of grout. Bolt, screw that down, carriage, countersink bolt head or whatever, and then come in with a cap flash over the whole thing. It gives you something to nail to, and nail to, and nail to, and any heavy wind blown, if this is a heavy enough gauge flashing, it's not going to cause you any problem. Wood rafters and joists, we've already talked about that. I showed you a detail of that. Pardon me, I had to check a Lone Star email. So here's some flashing details and weep hole. All right, we're back. I'm going to take a break. I'm going to take care of an emergency. All right. We got wall sections, various wall sections for masonry walls. Now, these details are all drawn as a semi-cavity wall, it looks like. But it can't be, because you got an anchor bolt down through this cavity with no detailing of grout in it. So one would have to presume that this is anchored somehow in grout, or if you're going to do this. I would build a header beam out of the masonry units like this, move this over here to the center of the block, and we would have an anchor bolt going down in through the beam, and perhaps through the center The core of the CMUs would be filled with grout and perhaps even rebar. But nonetheless, it doesn't matter. I'm going to move this header over here, this treated top plate over here. If you're going to leave the anchor bolt in here, it's going to have to be grouted. It's going to be a grouted cavity. Another option is this has a lintel. So if we get the pin out, another option would be that if this truly was an opening, you could still have a beam, and you could still have a steel lintel angle like that, and you could fabricate a lintel plate underneath here. This is belt and suspenders, and then this anchor bolt for your top plate could come on down. Well, that's not a straight anchor bolt, is it? Straight anchor bolt, and it could be welded to this plate or something of that nature. There are several options that could work. I would, if this is not going to be filled, but you're going to use a lintel in here, so I'd use a flat lintel plate, pressure grout this, and then drive that threaded rod down through that, and then fill it full of grout, and that should suffice. All right, but we have a top plate, and here's our roof rafters here, and here's our floor joist, and of course you're going to have to come along and bob your joist off to put your roof decking on. And then, unless you're going to have an open soffit, which is a bad idea because birds and stuff can get up in your attic, your roof, you're going to have to seal this, and then you're going to have an angled fascia board on that to finish it. And then when you put your roof decking up here, you're going to have your drip flashing and so forth and so on. All right. We've seen these walls before. This looks familiar, doesn't it? Again, I am not a big proponent for a row lock like this. You're asking for trouble. This grout will eventually heat and shrink, especially down in this area. In a heavy freeze, you'll get moisture mitigation in here, and these things will begin to pop due to freezing. Best thing to do is, like I said before, bring up both your courses flat like this. This is a precast concrete seal with a drip. Again, this is your drip stop, that little molded in, formed in cut in that, so that as the water begins to drip and sink back, because that's probably not set level, then the V will break the drip line and it won't drip back through here on the flashing. The better way to do this is just cap the bloody thing off with one big treated seal plate. And even though the top plate is not a seal, it's top, even though that is not going to have a rafter on it, that's something that you can put your parapet flashing, your cap flashing on and attach to it. And you can even go in your mortar joints here. That's too deep aspect ratio wise. It's one, two, three, almost 4 courses. That's way too deep. You'd stop that thing up here someplace. In reality, and that would be a much better solution, in my opinion. They do make a solid precast block that goes up on top. That's also an option. I don't think they show that in this page, but assume this is the roof up here. It would just be a precast concrete block that would be mortared in. So there are several ways of doing it. There are pluses and minuses and everything. It's a precast hollow core slab setting on a grouted bond beam or ledger beam. This beam needs to have rebar in it. Again, a neoprene pad, because this floor is going to move back and forth. It's going to want to. And then you put your finished stack on here. I don't know how they expect to get grout in there in this wall. You have to try to pump it, and this is shown as a cavity wall instead of a non-cavity wall. But that's okay. It's a detail. Not that you can actually build it. And since there's no tie rebar in here, I don't know why you'd grout fill the thing anyway. It's unless you want to try to seal off any water mitigation coming back in here. But they make end cap plugs for these things that would keep that from happening also. Let's see, what else? Metal decking with concrete. This would be a roof, open steel joist. There's your pocket. We've seen this before. Now, this is a precast, well, they do say it's a cavity bearing wall, so I don't know how they're going to hold some of this stuff without it. This would be fine. What say these were? Composite. Okay. Yeah, this is a part of the cavity, so there's nothing to hold that rod in there. Dot. Okay. Having an AARP moment. This is a slab on grade. This is your bearing wall for your foundation. This is called a brick ledge. In here, it's also referred to as a brick ledge. The brick's coming down. This is a bad idea to have your landscaping above your brick ledge. You really want your landscaping 3 inches below your brick ledge, because what's going to happen, Mama or somebody's going to want to put a flower bed in here, and instead of digging this stuff out, she's going to mound up crap, and it's just going to keep building up. It'll come up and blind your weep holes. Plus, you have dirt above your brick ledge, and this is a pet peeve of mine, because you will end up getting water mitigation in heavy rain, especially down here, through here, even though this is grouted and there's a flashing here. It's a bad idea. So keep your landscaping, your finished grade below your brick ledge. Plus, as well as you build this, I don't care how good you think your people are, termites love to dam up into this stuff. And will termites go into a brick wall? You bet they will. You bet they will. Now, will they eat your brick? No. But there's still bugs and stuff will crawl up in there. This is your flashing, and it's built as the walls is coming up. This is a cavity wall, again, and this is your load-bearing wall. This would be for a concrete wall. This would be a roof. It's shown here because they stopped this up here, so we're assuming this is a roof. And but if it is, you're going to need embedded flashing over that. So as you build your roof up, you can continue your flashing up, because you'll have to mask it, your flashing, with mastic against the parapet wall. If not, you'll have bad leak in here. We'll get to that in roofing anyway. I'm going to put the chamfer roofing material in there. The flashing will come down, and I'm getting ahead. I'm getting ahead of ourselves. All right, move on. Let's see where we at. Still kicking along? Yeah. All right. Okay. Reinforced concrete masonry wall. Reinforced brick masonry wall. Okay. This is, oh my God, this is from the ancient days of yore. Nobody does this anymore. Okay. No, nobody does this anymore. Wow, that's an ancient detail. It truly is. All right, well, we know what reinforced masonry wall is. It's a non-cavity wall. You got two whites, and you've got reinforcing periodically through here. Um, and So these masonry units are laid, um, they're turned, and that leaves a cavity that's full of grout and the rebar. Okay. They're building a little bond beam in the wall. Older brick buildings, when you had super good masons, and I've seen some of these details in some old warehouses down off of Washington Avenue, when they were converting those to nightclubs and restaurants and bars, and they hired us to go do a structural analysis of the existing old building. Some of them were built back in the late 1800s and early 1900s. Again, this is a brick ledge with a really funky cast in place floor here as monolithic. Wow. Okay. Wood joist with a metal strap embedded into the brick, and a ledger. Okay. A bolted in ledger. Another detail. This is how that other anchor bolt should have been done in that cavity wall. There was nothing to hold that anchor bolt, unless it was welded to a plate that the detail didn't pick up. But these joints are not that thick, so that would be kind of suspect for me. Anyway, again, we need to bob that. Carpenter needs to take care of that. I really don't like open soffits. They just, especially down here, we got too many critters. That would have to be closed off and sealed, and it just and then when you put your fascia board on that. But anyway, we've talked about that before. Here's a roof deck overhang. Remember we told you that the extension of a bar joist, you can get those with an extension already built on them. That's what they're trying to show you here. That was really a crummy sketch. Oh my goodness, wow. That's what that dotted line is supposed to be. Come on, pick it up. There we go. No, you want to draw or make a mess, whatever the case may be. All right, there we are on that line right there. Let's see if I can draw a straight line. Uh-oh, well, I went too far. I need to watch the screen, not my pad. All right, let's try it again. Oh my goodness, I think I need to be committed. So we would have an extension, remember, in the bar joist section. You can get them with an extension. There's a certain overhang, they called it. Okay. Well, you need to get with the manufacturer of that bar joist. Now, sometimes they'll just buy a regular bar joist like that, then they'll have their roof deck welders go weld these bayonets on, and that's okay as long as the structural engineer has looked at it, because depending on what this distance is, this now becomes what? A cantilever, right? A cantilever. All right. And you put steel deck up there, and you pour lightweight concrete, or you put in insulated panels, glue and screw them down to the steel deck, and then put your built-up roof on. And we'll talk more about that later. Minimum bearing length of 4 to 6 inches. So 6 to 12 for long span. Your mileage will vary. You get with your engineer, and you want to secure every joist to a steel bearing plate and a continuous reinforced bond beam. Okay, so this bond beam goes all the way around the top of the building and the wall. And if your bar joists are spaced, like, I don't know, let's say 24-inch centers or 3-foot centers, then you would have to be careful about setting these up when you're masons, because your masons are going to have to set these. An efficient detail, it's a little more expensive, but it covers a multitude of sins, is to do a continuous plate across the top of the bond beam. continuous steel plate across the top of the bond beam the bar joist sets on. And then you don't have to worry about spacing these, getting the spacing exactly right. So if you have a little oh no and you have to adjust these, you still have an anchored steel plate that's continuous on top that you can come in and weld to. And I'm a big proponent for welding these steel joist legs, plates, bearing plates. I'm having trouble talking. Wow. All right. Here's another precast hollow core slab. Now this makes sense because this is all going to be grout filled, right? Because it's not a cavity wall. So then the grout can pour in here as you're filling it with grout, whether you're pumping it out or you're actually packing it, quote unquote dry packing it as they're filling it in. Getting these cells filled is problematic. Then there's a lightweight concrete deck on top of these, because these do not set flat. I don't care how good you are. These do not set flat. You do need to pour a finish slab out of lightweight concrete or something like that. And it also fills in the grout keys between these. If you remember the floor section, these things oh my goodness, just like that, right? So yeah, so we pour this light concrete in here. All right. Okay. Again, they're on a neoprene bearing strip, and why is that? Because you don't want the concrete totally bearing on this. You want to give it some ability to move a little bit. Okay. All right. Let's see here. This is okay. This is below grade, so you're going to have moisture attacking this, as long as you put a vapor barrier, moisture barrier on the outside of your ground wall, your below grade wall. It can be up to there. People make all kinds of products for coating concrete, coating brick, masonry units for water mitigation. But remember, in order for this to be built, it has to be excavated, right? There has to be an excavation. And in reality, that excavation is going to be out here somewhere, and it'll start up here and go over here, right? Because you got to have forms. We'll line this up. Then you got to come in and pull the forms. And put this 1, 2, 3, 4, probably 5 courses of masonry units up. And then when this reaches its strength, then you're going to start your backfilling. You got to come in and you got to fill all this dirt back in, and you got to compact it. So it's not just the weight of the soil, it's also the energy that you're using to compact it. If it's a commercial project and it's being inspected, you're probably going to be expected to have 98% compaction. 98% compaction on the soil. So it's going to take some kind of mechanical action, which does add force against the wall. Your engineer and your geotechnical people will certainly help you. All right, let's see where we are. We're at 33 minutes. Okay, we're good. Okay, public service announcement. Listen very, very, very carefully. This PDF is the 4th edition, and it is correct. The later 5th edition is not correct. I've got the 5th edition on my desk, and I am going page by page with this PDF, this 4th edition, and the 5th edition, I don't have a 6th or a 7th, so I don't know what it looks like, but this is correct. They have the 5th edition and maybe the 6th and 7th. They have these two mixed up. This is a real row lock. This is a real soldier course. The 5th edition calls this a row lock, and this a soldier course. It is wrong. This is correct. This is correct. What we're going through is correct. Okay? So, you have been warned. You follow this video and what I'm showing you, or you'll get the definitions wrong. Soldier courses, if they're reinforced, there's nothing wrong with them. They're not as strong as a running bond. Okay, this is a running bond where the upper course is the joints, the mortar joints, is in a solid, above a solid masonry unit. Soldier courses are just like soldiers in a parade ground. They're standing at attention. In this case, this is reinforced, so those bricks aren't going to fall in. In a residential brick veneer house, you do a soldier course for me in a residential structure. My 50-year-old house, the top is, instead of them putting 3 more courses of brick veneer running bond, those goobers put a soldier course. Because that way they could just put 1 brick up, man. We can go home and drink a beer. With residential construction and this being brick veneer, what do you have? You have a detail that looks something like this. Here's your studs, wall studs. Oh my God. Okay, let's start over. Let's just start over. Okay. All right. Got a wall stud, other side of the stud. And yes, I've got the shakes today. And then you'll have an air gap, then you'll have an air gap, and there'll be an air space in between here. Now you size them up, complete. Joist will set in. And then, in my case, the second floor starts up here. And second story wall. Right here. You'll have the same tread. And then you'll come in, your brick will be walk in. Okay. Oh, that's not erasing. Bear with me. Computer is going nuts. There we go. It finally did it. Okay. Okay. So then the wall skin will come down. But in my case, what do we have? We have a soldier course. So instead of finishing 3 runs all the way around, then the outside wall is from TS, not too sure. There's outer skin and outer skin. And even though the lower course brick is tied back into the studs with little wraps, these soldier courses are unsupported. And so over the 50 years of this house's age, the mortar joints on the soldier courses, some of them have started to get weak and pull apart, as they will. And you got to be real careful. If you put a ladder up against this, these bricks will fall in. They break loose the mortar joint and they'll lay in here and let them fall where you have to get them out. I've had to go around this house and redo these soldier courses with epoxy. Because you take one, let's say these are good, and these are good, and that happens to be a broke loose one, then you got to pull it out, clean it up, and then go in there as far as you can with an epoxy grout, and then slide that brick back in there, and then rake and tool that. I've done this a lot, and it's a pain. So an unsupported soldier course is a bad idea. And I apologize for the really bad drawing. I've got the shakes this afternoon. All right, so let's go through the definition. What's a wythe? It's one row of brick, right? One stack of brick going up, okay? This is a wythe, this is a wythe, this is a wythe, okay? So this wall looks like it's 1, 2, 3 wythes thick. This up here was how many wythes? 1 and 2, right? Okay. This, if it's just a single CMU, it's 1 wythe, okay? A wythe is a continuous vertical section of masonry wall, 1 unit in thickness, 1 unit in thickness. All right. A course is a continuous horizontal range of masonry units. A collar joint is the vertical joint between 2 wythes, okay? So this would be a collar joint. A bed joint is the horizontal joint between 2 masonry courses. All right. So we have this course and we have this course, and that's the bed joint. That's called the bedding. It's where the grout's thrown up. And then these masonry units are set and leveled as the masons are building around the corner. Again, remember I said they start at the corners and then they build between the corners. Okay. The term bed may also refer to the underside of a masonry unit, but a bed joint, a bedded joint, a bed joint, or any of those forms is the joint between 2 courses of masonry. All right, the head joint is the vertical joint. Okay, that's it, a vertical joint. It's a head joint, that's a bed joint. Okay, these are terms that you may be asked to answer for. This is the real soldier course. This is what's called a rowlock. All a rowlock is a brick laid horizontally on the longer edge. It's laid on the longer edge, longer edge. So you're looking at the narrow end of the smaller end of the masonry unit. Okay, so the edge with the shorter end is exposed, and it can be laid flat or it could be laid vertical like this. All right. Okay. All right. Let's see. A header is a masonry unit laid horizontally with the shorter end exposed or parallel. So a row lock it's laid with the longer edge like this. A header is like this. It's laid flat, not vertical, looking at the smaller end. Okay, and a stretcher is a masonry unit laid horizontally with the longer edge exposed. So this is a stretcher. You see the longer edge. This would be a stretcher. That would be a stretcher. That would be a stretcher. Right? Okay. All right. And remember, soldiers are brick laid vertically. In this case, these soldier bricks are reinforced. But they stop your running bond. All right. Mortar joints. This is a concave joint. It's concave because the raking tool that they use to rake the mortar joint is concave. This is a V joint. They use the V tool. This is a weather joint. They use a regular trowel for this. And this is a weather joint. This is a struck joint. They just strike it off and go in at that angle. Now, the benefit of a weather joint, these are troweled using the mason trowel, and these are tooled with the shape. Okay. The benefit of the weather joint is as the rainwater runs down, it breaks it. And so you have these intermittent little drip edges instead of the water cascading down and pooling in here. Some people think it matters, some don't. This is a flush joint. They take the trowel and they just strike it off flush. All these started like that. The weather joint, the struck joint, they all started as a flush joint. And then if they wanted a weather joint, then they just take the trowel and cut it like that. Flush joint, okay, we just talked about that. All right. And then this is a rake joint. It's made by removing mortar to a given depth with a square edge tool before it's hardened. These generally, Ching says these are for interior use, which makes sense. Exterior, these things collect dirt and they collect all kinds of stuff. Well, all these will, but as rain comes down the exterior wall, it helps flush them out. Okay, so this is a V joint, it's almost like a weather joint. So a V joint is a weather joint and a struck joint, one could argue, but nonetheless, different kinds of joints. I'm not saying one's better than the other. Masons would love it if you just had them do a flush joint on all of them. It's less work, less hassle. They just strike that off with a trowel and move on up the wall. All right, course heights. Your mileage is going to vary a little bit between manufacturer and manufacturer. Okay. These are relative course heights or nominal dimensions that include the thickness of the mortar joints. For lengths, use multiples of 4 inches, 8 inches, or 12 inches. Okay. For brick types and sizes, you need to see chapter 12 of this book. It gives you nominal sizes, but the safest thing is get with Acme Brick when you decide what brick you're going to use, and get their nominal sizes for what you're ordering. Same with CMUs. Make sure that they're consistent with how you lay the stuff out before you start laying it out. And again, your wall thickness is going to vary with the type of masonry wall. We know that, right? So, and how you're going to insulate the wall and everything else. So let's look at what he says here. Okay. A modular is 2 3/4 inch units. 3 courses equals 8 inches, and that includes your grout, your mortar line, okay, which is what's called a bed, right? That includes your bed depth. All right. A Norman is a longer brick. There's an SCR brick. Okay. 3 1/5 inches. 5 courses equals 16 inches. This is engineered masonry, high structural masonry, high fired clay, usually with holes in them for reinforcing and grout. Think of a normal building brick with holes drilled in it. It's Norwegian, and then a Roman. Romans are narrower versus their length. You check your masonry manufacturer who you're getting this stuff from, and they should have everything you need for dimensioning out. Okay. Normal brick will be this modular. All right. Okay. Where are we at on time? We're at 49 minutes. Why don't we pick up here? So this is going to be video 5, and we are only on page 27 out of 40 something pages. Told you there's a lot of moving parts in this. Masonry's taken up a lot, isn't it? It's because there's a lot of moving parts. So we'll pick back up with this, and you'll find out I have another pet peeve for masonry. All right, well, let's go ahead and get this put up on YouTube.